Good morning. Today we're going to talk about the topic of rates and comparing ratios. The essential question for today's topic is, how can you use rates and unit rates to describe the changes in real-life problems? This lesson is from Big Ideas Math, pages 206 to 207. If you need to pause the video at any time to write down the essential question, or if I'm going too fast and you need to go back, feel free to stop the notes at any time. So rates are so important in our world. They are what we use when we go to the grocery store. If you're going to buy bananas, you want to know the price per pound at this store or the price per pound at that store, and so you know which one is the better buy. When we are getting a salary, you want to know how much you're going to make per year. If you're driving, you want to know with gas prices the way they are, what car has the best miles per gallon, and what gas station has the best price per gallon. So it's really something that we do use every day, and we're going to talk about what it means and how we can use this information so that we can apply it to situations within the real world. So rates and unit rates. Let's start with a little definition. So a rate is a ratio, and we've been talking about ratios and how they compare two quantities. So it's a ratio of two quantities. But these quantities aren't just quantities, they are quantities that use different units. And that is key. So they're comparing, for example, distance to time, or distance to price, or time to price. If you're doing, like, say you're mowing the lawn and you want to charge $5 per yard, you're doing the cost, which is a currency, that's one unit, and then the amount of yards would be the other unit. So you're comparing two different units. So that is really important. That's what differentiates a rate from just a traditional ratio. So there's two different units. A unit rate takes that a step further by simplifying the quantity down. So a unit rate is a quantity compared to one unit of another quantity. And that one unit is so important. So that's, for example, if we're at the grocery store and we want to buy soda, and we want to know, is it cheaper to buy the 12-pack or the 24-pack? Well, we really want to get down to where we're looking at what the cost of one can would be. So it would be like the price per one can. That would be a unit rate because you're only looking at the one. So that key idea of one unit is really important when you're looking at a unit rate. And so to find what one unit is, we take what the rate is, and then we divide it down so that we can get one unit down to one. And we're going to practice that. Now remember, equivalent means the same. So equivalent rates have the same unit so an example of that, same unit rate. I just needed to finish that phrase. An example of that would be you pay $27 for 3 pizzas. Okay? We would have it as $27. This is dollars, that's currency. We're looking at money. Over 3 pizzas. So our second unit is pizzas. Okay? So that would be a rate because we're looking at and comparing two different quantities. Now we want to get it down to where we want to know what one pizza would cost. We don't know what the cost is of that one pizza. So to figure that out, you have to look at this one and say, okay, what do I do to this number to get it to this number? What do I do to the 3 to get it to 1? Because I want to figure out what one pizza is. Well, I can divide 3 by itself, because anytime we divide a number by itself, we get 1. So I could say, okay, 3 divided by 3 equals 1. Okay. Well, just like what we did with equivalent fractions, whatever you do to the bottom, you got to do to the top. So 27 also divided by 3, well, 27 divided by 3 is $9. So one pizza costs $9, and this ratio and this ratio are equivalent. They have the same core unit value. So another way we can do this is we can use a double number line. Okay? So with the double number line, we could use one of those. So we're going to write the rate that represents the double number line. And so let's say we're playing a game. It's a video game. And with this video game, it's a music video game. And so you have to hit piano notes. And so when you hit those piano notes, you get 1, 2, 3, 4, 5. So let's say for every point you get, well, as you're doing the game, you realize at the end of the game, you hit 5 notes, and let's start with 0. So you hit 5 notes, and you realize when I hit my 5th note, my end score was 750 points. Okay? So these are your notes, and these are your points. You want to know if I hit 750 points, or I got 750 points out of hitting 5 notes, what do I get per each point? How many points do I get for each time I hit that note? So what you can do is we can make these little markers on our top bar graph. So these bar graphs kind of go together. And so we can say, okay, well, that's true. So if that's the case, what would I get here? Well, I have to figure out there's 1, 2, 3, 4, 5 markers, 5 lines, so I've got to divide this 750 by 5. Well, if I take 750 and I divide it by 5, I'm going to get 150. Okay? Awesome. So that means each of these places represents 150. So 150 more would be 300, 150 more, 450, 150 more, 600, and then we get to the 750 points. So now I know whenever I play the game, if I get 1 note, I'm going to have 150 points. If I hit 4 notes, I'm going to get 650 points. And it kind of gives me this idea of how this works. As the more points I get, or the more notes I get, the more points I get, or if I get this many points, this is how many notes I hit. So it's a way to keep track of our data and to find the rate. Now in this case, any of these times where these numbers match up, that could be considered a rate. But if I wanted to find the unit rate, I would look at where it hits 1. So here I have 1 equals 150 points, so my unit rate would be 1 to 150. All right, now I'm going to take this one more step. So I'm going to actually, because I run out of room here, I'm going to go over to my page 39, which is on my left-hand side. And I'm going to use a ratio table. So one way to compare ratios is by using ratio tables. And I'm going to create a problem, okay? So in my problem, it is going to be you mix 8 tablespoons of hot sauce and 3 cups of salsa. So I've got 8 tablespoons of hot sauce, 3 cups of salsa. I'm trying to make my salsa spicier. And that is in a green bowl. My green bowl has that mixture. Then in a separate bowl, you mix 12 tablespoons of hot sauce, and 4 cups of salsa. So 12 tablespoons of hot sauce this time and 4 cups of salsa in an orange bowl. Okay, I want to know, this is my question, which mixture is hotter? Assuming that our salsas are the same, our hot sauces are the same, and that the more hot sauce you have proportionately to the salsa, the spicier or hotter your mixture is going to be. So that's the assumption in this problem, okay? So what we're going to do first is we're going to figure out we're going to use the ratios to figure out the unit rate of both, okay? So we're going to make ratio tables. And plug in given ratios. This is going to be our step 1, okay? So, for example, on this one, I'm going to have hot sauce. And this is going to be in tablespoons. I'm going to simplify or abbreviate that. And then I'm going to have salsa. And that is in cups. Okay? This is my green mixture. Okay. I know that I have 8 and 3. So 8 and 3. Great. Now I can make my table the same way for my orange. So I've got hot sauce. I've got salsa. And in this case, I've got 12 and 4. Now, here's the thing. I could try to find the unit rate, which I could divide this by 3, divide 8 by 3, and figure out how much hot sauce is in 1 cup of salsa. It would be easy on this one, obviously, because 4 can go into 12 easily. Or I could do this a different way. I could make equivalent ratios that have the same value in either hot sauce or salsa. Which means I'm not going to find the unit rate. I'm actually going to make it bigger. So what I like to do is I like to find the one that's going to be the easiest. So in this case, if I look at salsa and I look here and here, I know that 3 times 4 is 12. That's going to be a nice small number. If I did the same with 8 and 12, I'm going to have to find a common multiple. It's going to be a lot bigger because those numbers just are bigger. So I'm going to go with 12. So I want to find now how much hot sauce would be in 12 cups of salsa on each one. To do that, I figure out now how many times this number goes into that number. So I'm going to find the missing term. Okay, well, 4, I know, times 3 equals 12. Well, remember, whatever you do to the bottom, you got to do to the top. So 12 times 3 is 36. 3 times 4 equals 12. Well, 8 times 4 equals 32. So now I know that if I have 12 cups of salsa, I'm going to have 32 tablespoons of hot sauce or 36 tablespoons of hot sauce. Well, that tells me that there's a difference of 4 tablespoons of hot sauce more in this orange table. That means that this table must be hotter, this orange bowl. So the orange mixture is hotter because it has 4 tablespoons more at 12 cups. The more salsa, or the more hot sauce to salsa, the hotter it is. So this rate, it has less of a concentration of salsa to hot sauce than this one. So I hope that makes sense. I hope that you enjoy this. You can actually also now take this and you can call this the X value and the Y value, and you can even graph it. So that, if we were to do it, would look like this. It's kind of an interesting thing. So we could take our data and we could say, okay, we could actually plug it in and start going over, and you would see that this one's going to get hotter over time versus this one because the value is different. So that's what we can actually then step up and do with this value. So I love doing ratios and rates. I think they're a lot of fun and they're super applicable to the real world. I mean, I don't know about you, but I want to know which hot sauce is hotter. Have a great day. Make sure to go back and rewatch the video or ask any questions if you need to. Bye-bye.